Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
In the 1960s, the United States decided to venture forth to the moon's surface. This new vantage point of space allowed us to look back at Earth's surface in wonder. Photographs taken by astronauts on the Apollo and Gemini missions fascinated the world and inspired a few to ask the question, could space be the solution for regular Earth observations? One piece of technology, dating to 1968, has since defined Earth remote sensing from space. It was initially doubted, but the little scanner that could defied all cynics to give us what we know today as the Landsat program. This instrument, called the multispectral scanner, or MSS, was designed and championed by Virginia T. Norwood, earning her the moniker, the Mother of Landsat.
The Landsat system is an amazing one. It makes you wonder if the MSS system hadn't been on board and operating, what would have happened to Landsat?
Virginia Norwood graduated from MIT with a degree in mathematical physics. Soon after, she developed a radar reflector that discovered previously untrackable winds. Her continuous successes got her a position at Hughes Aircraft Company. She was amongst the first women to join their technical staff, where she pioneered the first space-based multispectral scanner.
She said I was kind of known as the person who could solve impossible problems. So people would bring things to her, even pieces of other projects.
Norwood was working at Hughes when NASA initiated the Earth Resources Technology Satellite mission in 1967. As scientists at the University of Michigan and Purdue demonstrated, the future of land imaging was multispectral. They used this developing technology to assess the planet's surface on a more local scale. Multispectral devices like the MSS measure energy from the electromagnetic spectrum, including both visible and infrared light. The sensor acts passively, recording certain wavelengths of light reflected off the Earth's surface. These measurements are recorded digitally and transmitted to ground stations to be analyzed pixel by pixel, something that had never been done before. However, NASA and USGS both had reservations. The MSS was new technology, and they favored the return beam Vidicon, the RBV, designed by RCA to map the moon for the Apollo missions. The RBV used television tube technology to create a system of cameras, each filtered to a specific set of wavelengths or bands. They were limited to the blue-green, orange-red, and near-infrared bands. The system was analog, limited, and soon to be dated. So how to convince them to try multispectral technology?
People felt much more comfortable with that, even if they didn't understand the ramifications. And so we felt that there was a real bias because of that.
With the help of other innovators like Jack Lansing and Webb Howe, the prototype designed by Virginia Norwood was created for only $100,000, less than $1 million today. Her original designs included a scanner that looked at 6 bands of the electromagnetic spectrum. However, because the more trusted RBV system was heavier and larger, taking up more of the satellite, she had to cut back to 4 bands.
And really only a tiny corner of the spacecraft was allotted to the tiny little multispectral scanner. And no one knew precisely how it was going to perform, whether it would even work, whether the mirror would work, whether the digitized data would work. From the get-go, her superiors were saying, hand-wringing that this was going to be a problem. There was so much about it that was novel, and there was so much skepticism.
To allay NASA and USGS jitters about the much-doubted scanner, the prototype was stuck onto the back of a truck and taken on a California road trip.
This was because George Olaska said, nobody believes that scanner will work. I think you better give us some assurance. And so Jack Lansing and a couple of people took it out on the truck. And he was an outdoors type anyway, so he just thought it was great to get Tahoe and Yosemite and all those places.
The images were spectacular. The half-dome image still hangs on Norwood's wall today. On July 23, 1972, the Earth Resources Technology satellite launched into orbit with Norwood's sensor on board. Just 14 days after launch, a power surge caused by the RBV electronics physically rocked the spacecraft, and the RBV was immediately shut off. The first cloud-free image from the MSS was the Ouachita Mountains in southeastern Oklahoma.
I looked at those images and tears came to my eyes, and I said, it's everything we hoped for and more than we expected. It was, I could say, the highlight of my career and one of the major highlights of my life was to see that and to see that it worked and to think about what we could do with it.
Virginia Norwood, incredibly innovative, pulled off something that nobody thought would occur.
Virginia Norwood's MSS became the standard for the Landsat satellites. A 7-band sensor, a refinement of her original 6-band design, flew on Landsats 4 and 5, and went on to shape much of space-based land remote sensing, a field that has only grown since then. 50 years later, using technology that has evolved from Norwood's original concepts, Landsat satellites are still showing us more about the planet we love. In 2021, Landsat 9 launched into orbit. The data, now freely available to everyone, will bring about new scientific advances, helping us to better understand our changing planet.